For this section, we're going to start our discussion on radical equations, okay? So you've seen lots of equations in this course so far. We've seen linear equations in one variable, linear equations in two variables. We've talked about quadratic equations. We've talked about rational equations. So now radical equations. So when the variable in an equation occurs in the radicand, the equation is called a radical equation. So basically, an equation that contains a radical expression where the radical contains the variable, okay? So we're going to look at different things. We're going to look at some really basic examples, and we're going to look at some slightly more complicated examples as we go. I do want to remind you of something. You're not going to see it right off the bat, but hopefully you remember when we were in rational equations, we had this idea of an extraneous solution. So please remember, an extraneous solution is one that occurs algebraically but does not satisfy the equation. So you're not going to see it in the first example, but it will come up later in the worksheet, okay? So just kind of keep thinking of those extraneous solutions because they will appear before the end of this worksheet. Oh, my dog's outside. I was like, what in the heck does she have? She has like a little chew bone. Okay, so for topic one, we're going to talk about radical equations with square roots, okay? So here are the steps to solve. We don't know how to solve a radical equation. That's obvious. We haven't dealt with that yet. But we know how we could potentially remove a radical. So if we could remove the radical and then be left with something that we could solve, that would be ideal. So in order to solve a radical equation, you want to isolate the radical. So at first, we're going to have just a single radical expression in this equation. You want to isolate it, okay? Get it all by itself on one side of the equals. And then you want to square both sides of the equation. The way we undo a square root is we square it. So remember, if we have something like the square root of, let's just say a squared, we just get a. The square root and the exponent of 2, they just unravel each other. So the way we can undo a square root is just square it, okay? And then solve the resulting equation and make sure to check your solution or solutions, okay? You could have a situation where you have two solutions. So once we isolate the radical and then remove the radical, you're going to be left with either something linear or quadratic, okay? And you want to solve that so you have either one or two solutions, but always check your solutions, okay? So let's look at example one. So example one says solve each equation, check the solutions, okay? There we go. So for the first example, we have the square root of 4x plus 1, and then that equals 5. So we want to go ahead and work on the steps to solve this. You want to first isolate the radical. It's already been isolated. We don't have to worry about that. Step 2 says square both sides. So I would take the square root of 4x plus 1 and square it, and then I would take 5 and square it. Well, if I take a square root and I square it, remember they just undo each other, so you're just left with the radicand. The radicand on the left here being 4x plus 1. And then when I square the right-hand side of this, 5 squared is 25. Well, now I just have a really basic linear equation to solve like we did at the beginning of this course. I want to isolate my 4x. To do so, I would move the 1. I do that with subtracting. On the left, 1 minus 1 is 0. 4x plus 0 is 4x. And then 25 minus 1 is 24. And then I want to go ahead and isolate my variable. So I've got 4 times x. I need to undo that multiplication. So I would divide both sides by 4. On the left, 4 divided by 4 is 1. 1 times x is x. And then 24 divided by 4 is 6. And you need to check your solution when you're dealing, especially when you have an even index. So like when you're dealing with a square root, you have to check your solution. So we want to check x equals 6. So I go back to my original equation. And I've got 4 times 6 plus 1. We want to see if that really equals 5. Well, 4 times 6 is 24. 24 plus 1 is 25. And the principal square root of 25 is indeed 5. So we are good. So we can say with confidence the solution here really is 6. Okay? Let's try the next example. So we're still on example 1, but this time part B. So the first step to these directions say isolate the radical. So right now we have the square root of 3x plus 10. Outside the radical, we have plus 2 equals 4. We need to remove that plus 2. We need to move the 2 to the other side of the equation. We're going to do that by subtracting. Okay? So on the left, I have 2 minus 2, which is just 0. And then that radical plus 0 is just that radical. So we're going to be left with the square root of 3x plus 10 on the left, and then on the right, we just get 2. Now, at this point, we want to square both sides of the radical. So I would square the square root of 3x plus 10, and then I would square 2. Well, when I square a square root, remember, they just undo each other. They kind of unravel each other, and you're just left with the radicand. So on the left, I'm left with 3x plus 10, and then on the right, I just get 4. 2 squared is 4. And now we have, again, just a linear equation to solve. So I've got 3x plus 10. I want to move the plus 10 first. We've got to isolate the 3x, so I'm going to subtract 10. Well, 10 minus 10 is 0. 3x plus 0 is just 3x. And then 4 minus 10 is negative 6. Okay? Now, the last step for just the solving part is dividing both sides by 3x, or by 3 rather. We need to undo the multiplication of 3 and x. We do that by dividing. So I divide both sides of the equation by 3. On the left, 3 divided by 3 is 1. 1 times x is x. And then on the right, negative 6 divided by 3 is negative 2. But tap the brakes, hold on, you have to check your solution. So let's check x equals negative 2. So I get 3 times negative 2 plus 10 plus 2 equals 4. All right. Well, 3 times negative 2 is negative 6. So I get negative 6 plus 10 plus 2 equals 4. Well, negative 6 plus 10 is 4. So we have the square root of 4 plus 2 is 4. The square root of 4 is 2. So I get 2 plus 2 really truly does equal 4. So we can say that our solution really is negative 2. So that's kind of like the first and most basic example that we're going to look at. We are going to look at situations where there's no solution or you have an extraneous solution, but this is the process. Isolate the radical and undo the radical. If you're dealing with a square root, you want to square both sides. You could potentially have a situation where you have a cube root, and in that case, you would want to cube both sides, but it's the same process overall.